In this video, we're going to talk about how a monopoly firm can choose its profit maximizing level of output and price. The basic principle underlying profit maximization for monopoly is exactly the same as it was when we discussed this in perfect competition. In determining whether to produce an additional unit of output, a firm compares its marginal revenue and its marginal cost. If the additional revenue resulting from the production and sale of one more unit is greater than the cost of producing it, then profits rise when you produce that output, and therefore the firm will produce more output. So whenever marginal revenue is greater than marginal cost, output will always rise. On the other hand, if the additional revenue, the marginal revenue from the last unit, is less than the additional cost of producing it, the marginal cost, then the firm would have higher profits if it produced less output, and a profit maximizing or loss minimizing firm will produce less output. We have a maximum level of profit or a minimum level of cost at the level of output at which marginal revenue equals marginal cost, which is exactly the same condition we had for perfectly competitive firms. And in fact, this is going to be true for any profit maximizing firm, no matter what the market structure. However, the process is going to be just a little bit different here. A perfectly competitive firm faced a horizontal demand curve because it was a price taker. Because a monopoly firm is the only firm in its market, it faces a downward sloping demand curve. In particular, it faces the entire downward sloping market demand curve because it's the only firm selling output in this market. And this inverse relationship between price and quantity is going to result in some changes in how we measure marginal revenue. The downward sloping demand curve essentially provides a constraint on the firm. A monopoly firm can either choose the price it's going to charge or the quantity. Once it chooses one of those, though, the other is determined by the demand curve. If the firm chooses a price of $4, it sells 8 units of output. If the firm chooses a price of $3.50, it sells 9 units of output. Alternatively, if the firm wanted to sell 8 units of output, it would charge $4. If it wanted to sell 9 units of output, it would have to charge $3.50. So the monopoly firm is constrained by demand, but in a somewhat different way, because it gets to choose its price. And that's what we meant in the earlier video where we said that a monopoly firm can be called a price maker or a price searcher. This negative relationship between price and quantity, though, has an interesting implication for marginal revenue. Let's compute the marginal revenue of selling that additional unit of output, of going from 8 to 9 units of output. The initial revenue the firm received is given by this blue rectangle because total revenue is price times quantity, which in this case is 4 times 8 or $32. If the firm wants to sell the 9th unit of output, it has to lower the price to $3.50, and total revenue then will be equal to $3.50 times 9 units of output or $31.50. So again, selling 8 units of output, the firm had $32 worth of revenue. At an output level of 9, it has $31.50 worth of revenue. We can note that revenue actually declined. And we measure marginal revenue as a change in total revenue over the change in Q. In this case, the change in total revenue was a negative 50 cents when we went from 32 to 31.50. The change in quantity when we go from 8 to 9 is just 1. So we have marginal revenue of just negative 0.5 over 1 or a negative 50 cents. So in this case, marginal revenue is negative. Another way of seeing this is to look at the changes in revenue that occurs when we sell this 9th unit of output. In the diagram on the right, the blue shaded rectangle is the gain in revenue the firm gets from the quantity effect, from selling one more unit of output in response to the lower price. The area is equal to the price of that unit times the base, which is just 1. So that area is simply equal to this lower price a firm charges at 9 units of output. And if this was a competitive firm, that would be the only change that would occur because marginal revenue is equal to the price. In the case of monopoly, though, in order to be able to sell that 9th unit, it had to lower the price of the first 8 units by 50 cents each. So in that case, it loses that red rectangle. It lowered the price by 50 cents for each of the first 8 units, which caused it to lose $4 in revenue on the first 8 units that it used to sell at $4, but now it has to sell at $3.50 in order to have that one additional unit of output sold. So in this case, it loses $4 in revenue, it gains $3.50, and the net effect is a loss of 50 cents in revenue when the firm moves from 8 to 9 units of output. It may not seem intuitive that when the firm sells more output, it's going to have less revenue. We saw a similar concept when we talked about elasticity. One of the things we can observe in this case is that marginal revenue will always be less than the price. That blue rectangle, the gain from selling one more unit, is the price, but the change in revenue encompasses not just the price of that new unit. We have to subtract the loss in revenue from those other units, and with a downward sloping demand curve, we're always subtracting some amount, which is, again, the reduction in price on the initial quantity sold. It may not seem intuitive at first to have a loss in revenue when you sell more output. It comes down to the fact, though, that price and quantity demanded are inversely related. And we have this price effect and the quantity effect that we talked about earlier, specifically when we discussed the relationship between total revenue and demand elasticity. If you recall, we had a diagram very similar to the diagram on the right. We noted that along a linear demand curve, the demand curve is elastic at the top of the curve. The elasticity declines continuously as we move downward and to the right. There's some point at which demand becomes unit elastic, and beyond that, demand becomes progressively more inelastic. What we noted is that in the region where demand was elastic, quantity is changing by more than the price. So when the firm lowers the price to sell more output, it's gaining more in revenue than it loses from the price reduction, and total revenue is rising, as we see in the bottom part of that diagram. So when demand is elastic, total revenue rises. We noted that when demand becomes unit elastic, total revenue doesn't change, because if you lower the price by 1% and you sell 1% more output, those two effects just offset each other, and there's no change in total revenue. That's the maximum point on the total revenue curve. But once you get into the region where demand is inelastic, when you lower the price, quantity is changing by a smaller proportion, and the loss in revenue from the lower price has a larger effect on revenue than the gain in revenue from the additional quantity change. And in that region, total revenue is falling. So we can note that in the diagram on the bottom, total revenue is 0 at the 2 points where the demand curve crosses the price and the quantity axis, and total revenue rises in the range where demand is elastic, reaches a maximum at the point where it's unit elastic, and falls beyond that point. This diagram we have here is the same we had when we talked about elasticity and total revenue. The only change is the addition of the marginal revenue curve. In the region where demand is elastic, total revenue is rising, which means the change in revenue, the marginal revenue of an extra unit, is positive. But as we approach the point where demand becomes unit elastic, the change in revenue becomes smaller, and therefore marginal revenue is becoming smaller. At the point where demand is unit elastic, marginal revenue equals 0 because there's no change in total revenue. And in the region where demand is inelastic, total revenue is falling, which means the marginal revenue is negative in that range. So what we find then is that marginal revenue is positive when demand is elastic, 0 where it's unit elastic, and negative where it's inelastic. So that's where the marginal revenue curve for a monopoly firm comes from. And we're going to see this for any firm that faces a downward sloping demand curve. The marginal revenue curve will always be below the demand curve, and the marginal revenue is always less than the price. Remember, the demand curve tells us the price, also known as average revenue, and the marginal revenue at any level of output is below that price. So the marginal revenue curve lies below the demand curve for this market. Now, the decision in terms of producing output follows exactly the same criteria that we used before. You find the level of output at which marginal revenue equals marginal cost, or where the marginal revenue and marginal cost curves intersect. In this diagram, that occurs at an output level of Q star, where the upward sloping marginal cost curve and the downward sloping marginal revenue curves intersect. Anywhere below that, marginal revenue is greater than marginal cost and the firm would produce more. Anywhere to the right of that point, the additional revenue would be less than the additional cost and the firm would produce less. So that is essentially the same exact decision rule. Things become just a little bit different when we talk about the price. One of the most common mistakes that students will do is they'll find the point where marginal revenue and marginal cost curves intersect and just draw a line over to the price axis. That's incorrect. The reason is the curve that tells us the price that will be charged for any level of output is not the marginal revenue curve, it's the demand curve. If we want to find the price that the firm would charge to sell Q star units of output, we have to go up to the demand curve. And the price charged by the monopolist is a price given by the demand curve at the level of output at which marginal revenue equals marginal cost. To simplify this, the basic decision rule, and this also applies in perfectly competitive markets, is you always find the level of output where marginal revenue equals marginal cost, and that's the profit maximizing or loss minimizing level of output for any firm that stays in business. But to determine the price, you just go to the demand curve at that level of output to get the price. In a perfectly competitive market, marginal revenue and the price were the same, so we didn't have to worry about moving from the point of intersection. But in the case of a monopoly firm or any firm with a downward sloping demand curve, the price is going to be above marginal revenue at that output level. So this is a profit maximizing or loss minimizing price and quantity combination for any firm that finds it optimal to continue in business. The next thing we should do is determine whether the firm is making profits or losses here. We can't tell from these diagrams. To do that, we need to add an average total cost curve, which I've just done. We take the point where marginal revenue equals marginal cost, or Q star. We go to the demand curve, we find the price. The only other thing we need to know is the average total cost. And we determine average total cost by just finding the point on the average total cost curve where output equals Q star, and I've drawn a line over to the vertical axis at that point. If we look at the shaded rectangle, the height of that rectangle is price or average revenue minus average total cost, and that gives us the profit per unit. The base of that rectangle is equal to the number of units of output, and that's, again, exactly the same way we computed profit in the case of perfectly competitive firms. We take profit per unit, we multiply by the number of units, and that gives us economic profit. One difference, though, is that if this were a perfectly competitive market, the existence of these profits would cause other firms to enter the market, and that would shift the market supply curve, and those profits would disappear as new firms enter. But remember, this is a monopoly. If nothing changes, if there's no changes in demand or in cost, these profits could persist in the long run as well as the short run. Because again, we're assuming that there's effective barriers to entry, and this firm could continue making monopoly profits indefinitely, unless there's a change in cost or a change in consumer taste or some other factor that shifts demand. But this is assuming the monopoly is a profitable one. Not all monopolies are profitable. You may be the only producer of a product that nobody really likes all that much, in which case you might lose some money. So let's look at what happens if there's a monopoly that is losing money. In this diagram, we find the level of output where MR equals MC, Q star again. We go up the demand curve to find the price. But here, the price that's being charged is below average total cost, which we find by just going up to the average total cost curve at a level of output of Q star. So now the height of this shaded pinkish red region is equal to the loss per unit. The base is the number of units that's sold. So in this case, that would be the economic losses for the firm if they produce Q star units of output. Now, though, the question is, would they stay in business? Well, we have to think about what they would lose if they shut down. When we talked about this in the case of perfect competition, we noted that what the firm would lose if it shuts down is its fixed cost. Exactly the same argument applies here, and the fixed costs can be shown in this diagram. The fixed costs now are this shaded area, where the height of this bigger rectangle is equal to the average fixed cost, because average fixed cost equals average total minus average variable cost, and the vertical distance between the average total and average variable cost curves always equals average fixed cost. The base is the number of units, so that shaded region equals total fixed cost for the firm. If the firm stays in business, it loses this small rectangle. If it shuts down, it loses this bigger rectangle. So what we would see is that in the short run, it's only going to shut down if the price falls below average variable cost. That's exactly the same condition that applied in perfect competition. In the long run, however, all costs are variable. So there are no fixed costs. In the long run, monopoly firms have to cover all the costs. So in the long run, they would shut down if the price remained below average total cost. So in the short run, you'd keep this monopoly going because you still have to pay some fixed costs, which don't disappear if you stop producing output. But in the long run, you could sell off your building, sell your capital, and leave the industry in total. So you have to essentially at least break even to stay in business in the long run. There's also the possibility that a firm could be a zero profit monopolist. And let's see how that works in this diagram. At the point at which marginal revenue equals marginal cost, again Q star, we find that the demand curve is tangent to the average total cost curve, and therefore price equals average total cost and profit per unit is zero. And if profit per unit is zero, total profits are zero. Now this may not seem very likely, but there are a couple of conditions under which this may hold. One condition under which it may hold is that if you have a profitable monopoly and everyone has perfect information, the owners of that monopoly can sell the monopoly rights to a new owner, and the maximum price they could charge for the rights to take over this monopoly will just guarantee the new owner zero economic profit. Because suppose that we can measure all those future profits, and let's say all those future profits would be worth, let's say, $500,000. If the monopoly was sold for $400,000, the new owners would receive essentially $100,000 in monopoly profits. But if that's the case, everyone bidding for this monopoly firm would realize that, and someone would be willing to bid $450,000 and accept $50,000 in economic profits. Someone would be willing to bid $490,000. The bidding would essentially drive the price up to $500,000, where the new owner is just receiving zero economic profits. So, if a monopoly is resold and there's perfect information, we'd expect those profits to disappear. Exactly the same arguments apply if monopoly rights are auctioned off. And when the federal, state, or local governments lease out some of their property for private concessions, they generally do so through a public auction, and the maximum amount that someone is willing to pay to lease space on a thruway or a concession stand in a state or federal park or a local park would be the price that would just give them zero economic profit. If the price is anything less than that, someone else is willing to bid more. If the price is more than that, they'd lose money and they would not be willing to do that. So again, if a monopoly is resold or monopoly rights are auctioned off, we'd expect the new owners of the business or the people operating the business after that to receive just zero economic profit. So those are two exceptional cases where we might see this. We can note, though, that when we talked about perfect competition, we said there were two conditions that tended to occur. There was productive efficiency, so that firms were producing at least cost, and there was allocative efficiency because price equals marginal cost. Neither of those conditions are likely to occur for a monopoly firm. As we see in the diagram, even if the firm's making zero profits, that's occurring at an output level where average cost is higher than the minimum point. In terms of allocative efficiency, the issue comes down to price not being equal to marginal cost. In particular, the prices given by the demand curve is greater than the marginal cost in this new, slightly simplified diagram where we have a linear marginal cost curve. And I've drawn this as linear just so we can get a fairly nice, simple geometric shape to measure the cost of this. The same argument would apply if we had a typically convex marginal cost curve. If the market was perfectly competitive, the price would be set equal to marginal cost, and that would correspond to a price of P sub PC and a quantity of Q sub PC. So that would be the competitive price and the competitive output level. A monopoly, though, produces not where price equals marginal cost, they produce where marginal revenue equals marginal cost, but marginal revenue is less than the price. So what happens is a monopolist charges a price of P sub M, and the quantity produced is Q sub M. So monopoly firms will produce less output and charge a higher price, and that results in deadweight loss. The green shaded area in this diagram is a loss of consumer surplus that would have occurred under perfect competition. The brown shaded area is a loss of the producer's surplus that would have occurred under perfect competition. Consumers pay a higher price, monopolists receive a higher price, so some of the consumer surplus was transferred to the monopolist, but that's not a net cost to society. It's a cost to consumers and a gain to producers, but the total amount of surplus that's lost is that deadweight loss. And that deadweight loss will always occur when the price is above marginal cost. Society would have been better off if more output was produced at a lower price and there would have been larger gains from trade.